All right, so this is an isobaric compression from 9 to 3. Notice we've reduced the volume by a factor of 3. Okay. But anyway, so they tell us the number of moles that we have. So what we can do is just use our friend the ideal gas law to figure out the temperature. So PV is nRT. And so T is just going to be PV over NR, okay? So the T at A is going to be the pressure at A, volume at A, over NR, okay? So let's see, our pressure is 5 times 10 to the 5th. Volume at A is 9 times 10 to the minus 3. Number of moles is a suspiciously exact number there, right? 0.9025 and then 8.31. Okay, let's do this. 5E5. Did I get that right? I did. Okay. Times 9E minus 3 divided by 0.9025 divided by 8.31. And I get 600.018, right? And of course, that's because I just figured out what the moles were and tried to make it 600. Okay, so 600 kelvins roughly, right? Now, notice that at B, we've cut the volume by a factor of 3 from 9 to 3, right? So we would expect the temperature at B to be 1/3 of that, okay? And 1/3 of 600 is 200. So you could do it that way. I mean, that's what I would do on a test. But I know there's people out there that go, prove it. So let's do it. TB is going to be, the pressure is still 5E5. The volume's now 3E minus 3, which is 1/3 of that, which is why we're going to get 1/3 of the value, right? But I'm going to do this for the non-believers. All right, I'm going to do the same exact thing I just did, only I'm going to change the 9 to a 3, which of course will make this 200.006. All right, kelvins. So 600 and 200, right? Okay. And then B, find Q delta U and work for this process. Let's find the work. I think we can do work. Work is pressure change in volume. So that's going to be 5E5. That's our pressure here, right? Is that 5? And then our change in volume is, we go from 9 to 3. So it's final minus initial. So 3E minus 3 minus 9E minus 3. Okay? It's always final minus initial. Of course, you know this is negative work. That is the pistons moving in, but I'm just showing you why it is negative mathematically. Okay, times left parenthesis 3, E minus 3 minus 9, E minus 3. Obviously, I could just type 6E minus 3 negative in there, right? And I get that the work is negative 3,000 joules, okay? Let's see, so we found the work. Let's find the delta U. Delta U is going to be 3/2 N delta NR delta T. That's an R. Okay, so 3/2 N is 0.9025 times 8.31 times our delta T, right? So it's going to be 200 minus 600. I guess it gets colder, right? Because this is 600 kelvins. This is 200 kelvins. So delta U should be, all right, let's do this. 3 divided by 2 times 0.9025 times 8.31 times left parenthesis 200 minus 600 And I get that it's equal to negative 4,500 basically. It's 4499.865. I'm pretty sure if I included all these values instead of just typing 200 and 600, I would have gotten exactly 4,500. So you ask yourself, why is that such an even number when we're using random stuff like this, right? And the answer is that we can find delta U this way. It's 3/2 P delta V. We already figured out that P delta V is negative 3,000, right? So it's going to be 3/2 times negative 3,000, right? We just figured out this is P delta V right here. Okay, so the change in internal energy for one of these isobaric processes is 3/2 the work that you did. Well, 3/2 of negative 3,000 is negative 4,500, right? So now we can figure out the Q, right? We'll save this space to figure out Q, and this is terribly difficult. Q is delta U plus work. So Q is going to equal negative 4,500. And that's the delta U, right, is this guy. And then plus negative 3,000. And that is negative 7,500 joules. Woohoo! 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 Sorry.